Hello again. In this video, we're going to continue with section A.2, and we're on page 6, taking out a common factor. Taking out a common factor is backwards distributive law. Sometimes we use the distributive law to go left to right. That's what we have been doing. So you have A, start with A, parentheses B plus C, and you end up with AB plus AC. This is called distributing A over B plus C. Other times we use the distributive law from right to left. We start with the AB plus AC and we end up with the original. We call this taking out a common factor of A from AB plus AC, because we see A is common, so we write it on the left, and then in the parentheses you write what's left over. So for example, in example 5, let's rewrite each expression by taking out a common factor. We see here that M is common in all three. So what I'm going to do is I'm going to put the M on the left. It's not the only thing that's common though. We notice that an N is common also in all three. So I'm going to put an N with it and put it in parentheses. And then I'm going to go ahead and divide, right? What's left over. If I take out an MN, there's really nothing left, but it's not 0 because you're going to divide it. So it would be -1 plus taking out an M and an N here, dividing it, I would get 1M. And then here, we'll put a minus there, and we're going to take out an M, so that will be gone. Divide an N squared into N, and we end up with an N. If you multiply this out, you see, if you do a check, this is the answer, so you don't need to check it. But if you want to see that it does work, you multiply this to see you cannot get this to be 0, or you do not want the answer here to be 0, because then there wouldn't be anything to multiply to, which is why it's 1. If you multiply that together, you get minus mn, plus you get 2m, so m squared n, and then finally 2 n's, mn squared, which is what the original was. That is called factoring. You can do it sometimes when we add fractions. Another way of adding fractions is taking out the common factor. We see that this is 15 over 5 if you just added them. But if we can see the same answer by taking out a 1/5. So let's go ahead and do that. So what we left is just a 2 and just a 13. So you would get 1/5. Let me put a line here since that looks too close, of 15, which is 3, which is 15 over 5 is 3. So you can see it's the same thing. Finally, sometimes there's more than one, right? Notice how this is common. So we're going to do the same thing. We put the P plus R on the left, and what's left over, when you divide a P plus R, you have a T here, and the second term, you have a -7. And that would be the answer. So moving on to the next page, page 7, there are 2 exercises for you to try. The first is going to be going forward. Exercise 3 is going to be going forward, distribute and simplify. We'll practice that again. And then we're going to go backwards. Exercise 4 is what I did on example 2 on page 6, which is when we take out a common factor. We use the distributive property backwards. But let's try exercise 3 first. So go ahead and pause, try exercise 3. When you are done, resume, and we'll look at some of these solutions. Are you ready? Here's the answers. If you remember, I'll go ahead and do part A together. 6y squared, you could split this up into 2. There was 2 ways of doing this. I'll just go ahead and do it that way because 6y squared divided by 2y we know is a 3. 6 over 2 is 3, and we have 1y there. And then this would be 10 over 2 is 5, and the y's cancel. And that would be the answer. The other way of doing it is, if you remember, if you don't like that way, you can write it like this, and then go ahead and distribute. That's basically what I'm doing here, just a shortcut. So then that would be 2 goes into 6 3 times, and the y's cancel. And then the same thing. So you get the same answer. Part B, don't forget about the negative. So you do not FOIL here because you have a minus sign. We're just going to only distribute that -1. You're not going to distribute. A lot of common mistake is to distribute that whole 6 minus x. But it's just the 1, because if you remember, the distributive property is a multiplication. Whoops. AB plus AC, right? You have to have a multiplication here, and this is a subtraction. So you only distribute that 1. So it would be 6 minus x minus 5 plus x, because -1 times -x is plus x. And then the x's cancel, don't you? Don't they? And you get a 1. Part C, let's go ahead and do that together. Let's just distribute those. So what you have here is 3x times 2/3 minus 3x times 4 over x. The first one, when you multiply those, the 3's cancel. The 3's just cancel because it's like over 1. So that would be 2x. Minus here, the x's cancel, 12. That would be the answer there. And finally, this one is where you use the distributive property twice. You could do it the long way we learned, where you take x times that 2x minus 4 plus the 3 times the 2x minus 4, which would be 2x squared minus 4x plus 6x minus 12, or 2x squared. You might have done it that way. Or you could have just used FOIL. Let's move this a little to the left. And you would do the first, the outer, the inner. That's what these stand for. Inner. And finally last. I wrote this on the last page, but I'll write them again. I really meant the last video. We wrote these down. First, inner, first, outer, inner, last. And you can see you end up with the same answer. Both these answers are correct, depending on the way that you solved it. So that is going forward. That is using the distributive property in the forward direction. Now let's go backwards. So we're going to start at the end and get to the original. We're going to do that by taking out the common factor. So go ahead and pause, try this, and then come back for the solutions. Let's do the first couple together, since this is new. What is common? What is common in this one is a 2. Notice how this is 2 times 3 and this is a 2 there. There's something else common. You need to take out what sometimes I'll say, take out the greatest common factor, sometimes known as the GCF. So here, not only is a 2 common, but an x is common as well. I'm going to put a parenthesis now because I want to go backwards with my distributive law, and then I'm going to divide each of those instead of multiply. So 2 goes into 6 3 times, The x's just cancel and you have a y left over. And again, if everything cancels, then you have a 1. Here the 2 cancels, the x cancels, and you just have a z. And then you can do a quick mental check, because if you go forwards, it should always work, because we're going backwards here. So go ahead and try part B if you haven't already done so. Pause this now. Okay, so what's the answer? Did you get this answer? Did you get the 1? A lot of times people will put a 0 there as a common error. So a 2 is common, and you take out everything that's common. A P is common, and an R. That's all the things that are common, so I took out everything. So then I divide, and 2 goes into 14 7 times, and there's 1 P because the R's cancel. 2 goes into 6 3 times, the P's cancel, so there's 1 R left. And here everything cancels. You don't put a 0 because 2PR over 2PR is a 1. Part C. Let's do this one together. What's common? What's common is a 3 plus x. What's left? Well, if I divide the 3 plus x, there's a y common in the first term. I leave that minus sign and a 2 common in the second. And if I went forward, I would get this one times that, using the distributive property, this whole thing times that. Part D. The 5 is common. You just don't put a 5 because it's really 1 over 5. It's a fraction. So if you remember, this is the same as 1/5 x plus 1/5 y. So 1/5 is common. So what's left over is just the x plus the y. That would be factoring. Okay, E and F. If you didn't get those before, now try them. Otherwise, here's the solution. This one is actually kind of weird. I realize there's not a 3 there. Otherwise, I would say B plus 3 is common. So I'm not sure. That might just be a typo. Might not be in your new book. That's a 3, because I have the old book, and he said he was going to fix some typos. Then I think that that's what he meant there. You would not get this answer that I'm getting. But if it is a 3, it isn't a 3, it's an x, then it would be, I might as well do it as it shows. The only thing I can think of is multiplying this out. But if I do multiply it out, there's going to be nothing that is common. So at this moment, it does not factor. So we get that. You can see nothing is common in the whole thing. Nothing's common here, nothing's common here. So this one does not factor. This was just a check to make sure. But that's really the answer. Sometimes they just don't. There's nothing common. Again, that's probably been changed, and that's a 3 in yours, and then there would be an answer. Okay, so let's try this one. X plus 4 is common, and what we have left is 4ax. Oh, this one's tricky. Minus 2z. This is not factored completely, because when I notice here, a 2 is common. So I could take an additional 2 out and get 2ax minus z. And I like to put my 2 here instead of there, the extra 2, but either way would be okay. Now, if you happen to notice that a 2 is common at the beginning as well, unlike what I did, a 2 is common and the x plus 4, you could have done this all in one swoop. right? Because then what would be left over is this.